All right, ladies and gentlemen, quiz number 8. We're almost there. 8 and then 9. 9 is just a couple of questions. So 8.2a is true. And it's true because n times p is equal to 20 times 0.77, which is equal to 15.4. And q, n times q, or n1 minus p, is equal to 20 times 0.23, which is equal to 4.6. So we know that the distribution of p is not approximately normal. In most samples, we expect b to be close to 0.77, the true population proportion. So that's why that is true. B, false. Unlike with means, for the sampling distribution of proportions to be approximately normal, we need to have at least 10 successes and 10 failures in our sample. For this, we do not use n greater than or equal to 30. We use this. Okay, C, false. The standard error of P comes out to be 0.0384 with n equals 60. And so then you do the standard deviations, and it's 2.08 standard errors away, so it's unusual. And D is true. You do the same thing as the other one, in which your standard error is 0.046, and when you transform that into a Z, it's 1.73, which is within 2 standard deviations, or 2 standard errors. A, with a random sample of less than 10% of the population, independence is satisfied because it's random. Okay, random. Independent. Okay. The success failure condition is also satisfied, hence the margin of error can be calculated, and then you just plug in your margin of error is about 3%. B, 95% confidence interval for the proportion of those who think licensed drivers should be required to retake the road test. You have the margin of error from the previous one, so you have 0.66% or 66% plus or minus 0.03, and that is your margin of error. Okay, and since 2/3, or about 67, is contained in the interval, we would not reject a null hypothesis where p is equal to 0.67 because it is included in your 95% confidence interval. For A, 8.8a, 61% is a sample statistic. Sample statistic. It's the observed sample proportion. For B, 95% confidence interval, you have it, you know the formula, 0.61 plus or minus 1.96, and then the standard error, right? And you calculate the standard error, it comes out to be 0.586 to 0.634. And that's your confidence interval, C. Independence, the sample is random and comprises less than 10% of the population, therefore we can assume that the individuals in the sample are independent of each other. Again, randomness. Okay? Randomness and independence. And 2, success failure, the number of successes and the failures are both greater than 10, therefore success failure condition is met. Okay? Success and failure are both greater than or equal to 10. And that meets that condition. And then for D, the interval is about 50%, suggesting that with 95% confidence that the true population proportion of Americans who think marijuana should be legalized is greater than 50%. Right? All right. Margin of error calculations are always tricky, but in this case, it is your Z critical multiplied times P1 minus P over N. right? And we want a 2% margin of error, so 0.02 greater than or equal to 1.96, which is our C critical, over P 0.61, and then Q 0.39 over N, right, which is what we're trying to find. So then we just do some algebra, and N turns out to be greater than or equal to 2285. And you always round up to the nearest whole because you cannot have a decimal of a person. But know how to do, this is a hint for the final, know how to do some algebra here. Okay. 816A, no, it is not reasonable to use a normal approximation because under the null hypothesis, the expected number of users is 2.5. Since the proportion is less than 10, the proportion of successes is less than 10, the normal distribution is not a good approximation. Okay, remember successes and failures both have to be greater than 10. B, the hypotheses are P is equal to 0.05, and the other one is P greater than 0.05, where P is the proportion of 18-year-old women in the neighborhood who take birth control pills. The p-value is represented by P greater than or equal to 6, in which the p-value that we get is 0.038. And C, there is sufficient evidence to reject the null hypothesis. Why? Because it's less than 0.05. Reject the null and accept the alternative that the proportion of 18-year-old women using birth control in this neighborhood is higher than the national average of 5%. Okay? Sorry, this should be A. Reject the null. Alright, A24A. The hypotheses are the null hypothesis, P of V equals P of NV. The alternative is P of V does not equal P of NV. So under this one, again, equality. There is no difference, and here there is a difference. B, independence. So the sample is random. Okay. We can safely assume that 254, less than 10% of all mothers of autistic children, 229, less than 10% of all mothers of children with typical development. Therefore, whether or not one mother took prenatal vitamins during the 3 months before pregnancy is independent of another. And then success and failure. Remember, independence, randomness, success, and failure. What did we say? It has to be greater than 10. I'm trying to write on the tablet. My handwriting is all weird. Okay, so yes, they do qualify for that success failure, and then we calculated this test statistic and the p-value. So remember, you need to know, right? You need to know p q over n plus p q over n, all square rooted. And that comes out to negative 2.99. Sorry. Under 0.47 minus 0.61, the two proportions. Negative 2.99. All right, and then we get the p-value, which is a very small p-value, 0.0028. Because it is less than 0.05, we reject it all, go with the alternative. The title of the newspaper article makes it sound like using prenatal vitamins can prevent autism, which is a causal statement, right? Since this is an observational study, we cannot make causal statements about these studies. All right, 828. I'm just going to give it to you straight. It is true, true, false, false. Why are these false? The first one is false because the chi-square distribution is right-skewed. And the p-value is defined as the p-value of chi-square being greater than the big chi-square. Therefore, we will only shade the right tail. False, the variability increases as the degrees of freedom increases. increases, or rather, like that, as the degrees of freedom increase. Okay. A, the null is that the outcomes are independent of which treatment a patient received. The alternative is that there is some dependence or some association of the patient outcome with the treatment they received. Okay, this is what independence, association. And B, the p-value is smaller than 0.05. Therefore, we reject the null and go with the alternative hypothesis. Or another way of saying it is a strong evidence that some treatments were better or worse than others at treating lymphatic filariasis. All right, I don't know why it didn't record 840, but here the null is that the distribution does not follow an association. The alternative is that it does. We are not told about independence, but our sizes of our cells are all greater than 5, so that's good. And then we do our chi-square statistic. Remember, observed minus expected squared over expected. All added up together gives us 277.48 with 3 degrees of freedom, which is a very low p-value, and so we reject the null hypothesis. And the last one here, the odds ratio for survival. So A, the odds ratio for survival comparing treatment to control is 14 out of 26, all divided by 11 out of 39, which is 1.91. While this is the odds ratio, while your relative risk is 14 out of 40 divided by 11 out of 50, which is 1.59. So the estimated odds ratio, estimated odds of someone on the treatment groups is approximately 90% greater than someone on the control, right? Approximately 90 or 91% in this case. The estimated conditional probability that someone in the treatment group survives is approximately 60%, 59, right there. C, the relative risk is more interpretable and more natural way to compare the chances of success between 2 interventions, and we should use it whenever possible, or you can always translate odds into probability if all you have is odds. It's kind of, it's not incorrect, but it's kind of less intuitive. All right. And with that, ladies and gentlemen, we have finished section module number 8. Any questions, comments, concerns? You know how to get to me. Thank you.